Okay, guys, welcome back again. Okay, today we are going to discuss the major phase, which is the second step in our the math. So basically, major you need to identify something we call the rule of taking the sample, and also in this phase, you will be able to know the methodology of taking sampling. Okay, and because in the analyze you cannot analyze for example million of data or thousand of data, so you need to take sample in the major phase, sample of the population, and then you can analyze it in the analyze phase. So first of all, uh, this is Lord Galvin, and he is a Scottish mathematic. What he is saying here, this is what we said yesterday about the problem, about introducing the problem, about explaining your problem to the stockholder. So here he is saying, uh, if you can measure what you are speaking about and express it into number, okay, this is it can be like uh, convincing to the management. But if you are whatever you are speaking about, you cannot express it to the number, that means you don't have enough knowledge about what you are talking about. And at the end of the day, this one cannot be satisfaction to the recipient to whom you are talking to. For example, if someone asks you, or you are calling someone and you are telling him, I have increasing my weight, or my weight has been increased. So the first question he will ask you, how many kilo right now your weight? If you said I don't know, I'm not sure about, so in his mind he cannot imagine how much you are fat or thin. Your weight increase, but increase which in which state? What means it's dangerous for your healthy, above 90, above 100, or still you are in the safe side like 80, 81, 82. So he cannot have that picture in his mind until he give him a number. So once you give him a number, he can give you if you are on the safe side or not. You need to do diet or not. You need to have more time practicing sport, any kind of sport or not. So this is what we mean by whatever you are talking about, you need to express it in a number. So once you cannot express it to the number, that means you don't have enough knowledge about what you are talking about. And the end of the day, it is not be satisfactory. It's not be convincing for the recipient. Okay. In the major phase, we have three things we will talk about. We will talk about measuring, as we said, project sampling, how we'll take the sample and which type of the sample that we have. And then you will decide the MSA. MSA, it's about measurement system analysis. We will tell you this is the two type of result. To measure equipment, you will use it, and then you will get the two result of after the measuring. Which one you will prefer to take? Okay, this is we will see it, and then we will go for something we call it process capability. Process capability means you have a process, you have a procedure. How you know this process and procedure is fulfills the requirement for the customer? So you need to examine it, you need to test it, you need to measure it until you know if it is valid or not, if it is capable of achieving customer satisfaction or not. Okay. Here, the first step, as we mentioned in the measure phase, is to identify the measuring sample or the measurement sample. So in this phase, you need to take a sample. This is the first thing you need to know in this stage. In the measure stage, you will take the sample. So why we are taking the sample? Why the sample is very important for us? So this is we will know. So the third stage the third stage in the data analysis is not practical to analyze the data because you cannot analyze millions of hundreds of the data in the analyze phase. So in the measure phase, we will prepare you. We will take a sample from the data so you can rely on the data you take or rely on the sample. The sample will represent the whole data. So sample means you will take some from the data and you will make a measure and then you will analyze. If you will take the whole data, we call it population. So just be careful about it. Sampling means some of the all of the data. When we said I'm going to work on the population means I will take the whole data. Whatever the whole data is, 10, 100,000 million, I will take it. But it depends on the size of your team. It depends on the size of your Six Sigma project. But in fact, in the real life, all the project will take the sample because you cannot analyze thousands of data or cannot even measure thousands of data. So why taking a sample or sampling is very important. So sampling, it's a process collecting only a portion of that. Only we will take some of the data. We will not take the population. This is we call it sampling. We have an example later on. In the next slide, we will see. Okay, only taking a portion of the data that may be available and using the data sample draw conclusion. We call it statistical inference. So all it's about overall data in general size larger than sampling. Representation of the whole large which result in the greater reliability. The conclusion of this one, we will take part of the data, okay? We will take a sampling from the population, but you have to be aware and you have to take care of taking sampling from the population. You need to represent all the population, okay? We will go for the next slide. There is a example. We will explain it more. But there is a one fact we need to address here. In a perfect normal distribution, this is a general observation. 99% of the data lies between up and down, plus and minus 3 sigma. 3 sigma. So the general observation, all the data you will collect, all the data you will sampling, it's the result for that data, it will be between up and down 3 sigma. That means you are working on the 3 sigma level, okay? And this is the accuracy number. We call it the yield or the accuracy of the 3 sigma level. So whenever you have this number, that means you are working 3 sigma level. So this is we need to take care about. Whatever in the red, it will be in the exam. This is a question in the exam. This is also a question in the exam. So you have to take care about. Okay. Let us take this example, so we will have more idea about sampling. Okay, we have 50,000 data or 50,000 items, and we need to take only 100 as a sample. The question here, from where you will take this 100. You will take it from here, from the beginning. Imagine this 50,000 in the table. Okay, there is a table. This table contains all the 50,000 data. Okay, this is the Six Sigma team. They decide they will take only 100 out of 50,000. Okay, and we will make our measure onto this 100. So from where you will take this 100? You will take it from the top, from here, or you will take it from the middle, or you will take it from the last. So in Six Sigma, we will tell you, don't go for this. So each unit or each, we call it unit. Later on, we will know. So each sample, it has to take the equal opportunities. They have to take equal chance of taking. So if you're taking from here only, okay, maybe you will take the data which have the more defect, more errors in this data. So if you measure only this data, it contains the most errors, the most defect. What will happen? That means the result, it will come about all defects. So the Six Sigma level will be very low. You will even 1 or 2. Why? Because 1 or 2, because you took from here, and this is all defect. Also, maybe you will take it from here. So here there is none defect. There is no any defect. We call it free defect. So once you take the sampling from here, it is all correct. It is all 100% accurate. So what is the Six Sigma level will come? Will come to you 6 or even 7. So this is totally wrong. Okay, even if you take it from here, for example, and all defect, again, it will be, this is very bad or very bad selection. So how I will take this 100? Here we will tell you. This is 100. What is the law here? You will divide it, the 50,000 into 100, okay, and the result you will take it as a sequence. Okay, what that means? 50,000, when you divide it by 100, how much it will give us? 10. Correct? Correct, guys? 10? 10 or 5? 5, correct?
5.
Yeah, 5. Okay. That means what that means? From each 5 items, you will take 1. So this is, you have fairness, and there is a chance for each sample to be taken as a sample, or for each unit there is an equal chance to be taken as a sample. So now what will happen? Now from the top to the down, okay, this is the top of the table. You will calculate 1, 2, 3, 4, 5. You will take 1 from here. You will take 1, 2, 3, 4, 5. You will take 1 from here, and so on. So now you have accuracy. Okay, this is, we call it factor of sampling. This is, we call it here. We call it factor of sampling. What is the result of factor of sampling? You have degree of accuracy. Okay, instead of taking from top or down, so you will take it now with the fairness, with unbiased. We will see it later. Okay, now you will have more accuracy. Okay, now you will have more time. So instead spend your time only in addressing one at the top, or one in the middle, or one in the bottom. So now you have time. You will have more time. Okay, availability of the money. This is also one factor. So you will save more money. Okay, the size of questionnaire, like a survey, you will take it. It will be more easy and less. Okay, there is another factor is the size of the whole means the size of the population. As we said, the whole of the data is not like it doesn't matter for you. It is 50,000, 100,000, and even 1 million. So you have the technique for taking the sampling. So the size will not be matter for you. Also, the number of resources available. If you don't have any kind of resources, sure, when you're collecting the data, you need resources. So this kind of resources, when you take the sampling in the correct way, these resources, it will be less cost when you're taking the whole population. If you take the whole population, that means you need to address and analyze and measure the whole data, and this will take time, it will take more resources. But if you are taking one sample, instead of 50, you take only 100, and this 100 will be more accurate, to give you less time, low cost, and the questionnaire or the survey will be low, and the whole data or the population, it doesn't matter for you, and also it will reduce the availability, or it will reduce your necessity of the resources. Okay, now here we have two types of sampling, means two ways of taking the sample. We have something called random sampling. Random sampling means each one of the data, okay, of the data of the sum, means from the population, it has equal and no chance to be selected. So it has a chance to be selected. If it is in the top of the table or in the middle of the table, when you calculate 1, 2, 3, 4, 5, this is a 5. So from this side, I have to take one. Maybe I will take this one or this one. So there is an equal chance to be selected. So what is the benefit of taking random sampling? It's unbiased. Unbiased means there is a fairness. There is a fairness on taking the sample. You are not going to take from one side and leave the another side. So there is a fairness, and there is equal, and there is no discrimination for taking any of the sample. Also is representing the population, as I mentioned. Okay, once you take 5, and from the 5 you will take 1, another 5 you will take 1, another 5 you will take 1. In this case, you will represent the whole population, or the whole data. Also, it is very simple. It's very simple. No need to bother yourself. Okay, economical means it will reduce the cost, as we mentioned earlier. If you are working in the whole population, it's not same like you are working in the sampling. Whole population take more time, and time equal to money. If you are taking only the sampling, so sampling, it will be simple, easy, and low cost. We have something called another type of the sampling, systematic sampling. Systematic sampling, during my explaining to the sampling, I already explained that one. What means? It's random, but random orderly. So orderly manner. What means? Randomly we will take 100. We'll take 100 from anywhere, from the top, from the down, from anywhere. No, systematic, okay, we tell you, okay, I will tell you, go and take random, but make it little bit orderly. So from each 5, take 1. And from each type 5, take 1. And the one, it will be equal. Maybe you'll take the first one, or the second one, or the third, or the fifth. So this is the difference between random selection or random sampling and systematic sampling. Okay, guys, here we call we have something called MSA. This is the number 2 on the measure. So we said number 1 in the measure, we have sampling. Number 2, we have the MSA. Number 3, we have what we call it process capability. So number 2, we have MSA. MSA, it's about measure system analysis. So what means? Determining the difference between observed value without measuring, and the actual value using the measuring system. This is what we call it MSA. What that means, you have a data, you have observed data, okay, and you have actual data which is in front of you, which is in the table. So you need to take a measure. You need to measure this data. So in order to make to measure this data, you need to have a tools, or you need to have a measurement. If you are going to measure your weight, you will get in the scale, you will measure your weight. If you need to measure your body temperature, there is a thermometer you can. So in each measure, you have to decide which measure you will take. So why we are mentioning this here? Because during your analyzing, during your measuring the data, many results it will come. There is a result with the decimal numbers, 0.000 something, nothing, 0.1234, and it will give you also one number, or the actual number 14, for example. There is no any point 0011 whatever. Okay, this is, we'll take example for that one. So this is one you have to be believe on. You are a Six Sigma professional. You have to believe there is a defect in each process in your company. You have to be like doubtable. You be spiritual. You have to be spiritual. You have to doubt any kind of process you have it in your company. You have to doubt all the procedure. What means? You will believe in each process there is a defect. In each process there is an error, and you need to take it out. You need to remove it from the process. So why is this one? This one, it will, what we said, like implementing the continuous improvement in the process. If you don't believe there is an error and defect in this process, then you will not be able to improve it. So you have to be believe, you have to put this belief in your heart, there is a error and defect in each process. So once you have this belief, then you will work on the continuous improvement. Then you will work on the process restructuring. Then you will work on the procedure improvement. Okay, guys. So you have to be spiritual, and you have to consider continuous data. Okay, it will give you always there is a decimal number. It will be in the continuous data. So for example, it took 14 point this number, okay, in order to transfer file per second from one location to another, okay, and we using this another measurement. It gives us, it took only 14 seconds. So which one you will prefer to take? Which one you will depends on? Here we will tell you that this is, it depends on you. You have the choice which measurement you will use, or measurement tool you will use, which is system of the measurement you will use, which MSA you will use. What that means: if you are working on a financial project Six Sigma, you have it for it's working for finance. In finance, this number is matter. Okay, this number is matter. So finance, for example, collection. If you said you collect 1,202.234 halala, or 2224 halala. This halala for finance, it's a value. It is very important, because this one, if it's repeated 223 times, it will come 1 real. If you repeat it again, it will come 1,000 real. So for finance, these numbers is matter. These numbers, you have to take it with you. So that means when you are working in finance, you have to be accurate, and you have to take the measurement system, which it will give you more accuracy in the number. But if you are working in the HR, and HR you measure the resignation, for example, how many people has been resigned from our company. They will tell you the average of resignation is 14, okay, or 14.5. 0.5, it doesn't matter here. 0.5 means what? Half employee. For you as HR, it doesn't matter. Only I need the 14. So this is what means to decide which MSA you will use, which is the measurement system you will use. If you are working in one area, it is a sensitive area, need even the decimal number, you have to use which is a measure will give you the decimal number. If you are working in HR, if you are working on IT, in any kind of any department, for the decimal number or the point is not it's not important for you, then you can take it rely upon this MSA. So this is what we mean by MSA. This is what we mean by how to decide which is a measurement system you will take. Okay. Sometimes the measurement or MSA, we call it GAG or requirement. Okay. Okay. Process capability. Let me go to the Excel before I explain what is the process capability. We will go to the Excel. We will we have one sample. We will explain that sample and one example, sorry. Once we finish the example, already this one, it will be no need to explain it. Okay. Just be careful here, guys. Today, you will learn how to calculate your Six Sigma level, which in which level you are working right now. Okay. We have this example. So what is this example about? Actually, this is, sorry, I forget actually to translate. This is electricity. Okay. This is water. Yes, I will take it quickly. Okay. This is AC. This is doors, and this is
network
window. Okay. Okay, guys. So now, what is this one? This is, we have real estate, and this real estate, they are managing more than 3,000 villa or 3,000 apartment or whatever. Okay, they have 3,000 villa or 3,000 apartment. We took sample from each one. We took 5 villa only. Okay, so we took 5 villa. 5 villa means, what means 5 villa? Means the number of sampling. How many number of sampling we took out of 3,000? Okay, guys, out of 3,000,
this is
we
random.
took only 5. So this 5 is representing the population. The population is 3,000 villa. So from this 3,000 villa, we took only 5. So in Six Sigma, what this 5 we call it? We call it this the sampling. How many sample we have? We have 5. So in
Random.
Sigma, we call it unit.
Random sampling.
Yes, this is random sampling. We take 5 out of the 3,000. In the real life, you will take more. Actually, you will take 100, for example. You will not take 5. But for the teaching purpose, we will go through 5 only. So to increase, no need to waste our time on. I guess we need to take the whole idea. So out of 3,000, we took only 5. So what is 5? 5 is the number of sampling. What means number of sampling in Six Sigma? Number of sampling means number of unit. Okay, guys, what means unit? Unit means the number of sampling you have took or you have been taken from the 3,000, which is the population. So the number of sampling, we call it in 6 sigma unit. Why we mention this one? Because after 2 minutes, we will go to the 6 sigma calculator. There is a special calculator designed for 6 sigma only. So in this 6 sigma calculator, there is nothing called number of sampling. You will find it number of unit, only unit even. They will write unit. So when you ask you for the unit, you have to put 5. 5 what? 5 is a sampling has been taken from the population. Okay. We have here electricity, water, AC, doors, and windows. What is this one? This one we call it parameters, or we call it evaluation parameters, or the parameters of the evaluation. What that means? You need to evaluate this 3,000 villa. So in which one you will test it, in which one you will examine, in which services you will examine. We will examine on the electricity and the water and the AC and the doors and windows, for example. Okay, if you are working on HR, for example, you take 5 employees. So what is the parameters you will, or the evaluation you will take? You will take from, for example, qualification, communication skills,
Experience.
for example, what
Experience.
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 Okay, like this. So you get the idea. This is, we call it the parameters or evaluation parameters, and here the sampling. Okay, so what is this one? Error, defect, error. Error free means there is no defect. That means there is no issue in the villa number 1. There is no issue in the electricity, but there is the issue in the water. What means error, defect? That means there is the error here. Okay, so when it comes to the AC, error, that means there is the error, there is a defect in the AC. When it comes to the door, there is an error in the door. When it comes to the window, there is no. It's free of error free. That means there is no any defect. It is 100% working. So what this we will call it? We will call it opportunity per unit. Okay, we will explain it later on. So how many parameters we have? We have 5. We could have 6. We could have 7, 8, 9, whatever. It depends on you. Okay, the parameters we have 5. Okay, and how many units we have? We have 5 units. Okay, this is just what we call it. We need to sort, or we need to organize how many defects we have, because we will use it. So the number of defects, number of errors that we have, this is very important, and you need we need to take it with us in order to put it in the 6 sigma calculator. Okay, let us go one by one. In the villa number 1, how many defects we have? We have 1, 2, 3. Just put it here, 3. Villa number 2, how many defects we have, or error? 0. We don't have anything. Villa number 3, how many defects we have? 1, 2, 3, 4. We have 4. Villa number 4, we have only 1 error. Villa number 5, we have only 3 errors. 1, 2, 3. So the total of error is 11. Okay, guys. Now this is the first number we need to take it with us. No, second number. We have the unit, and we have the defect or the error. How many error we have? Okay. We have something called the total opportunity. Total opportunity equal total sampling. This is the one. Total sampling into the total parameters. This is the total sampling. 5. How many parameters we have? We have 5 parameters. Which is 5 parameters? Window, door, AC, water, electricity. We can add, for example, backyard or whatever. We can add whatever. But in the current situation, we have 5. How many units we have? We have 5. This is the 5, this is the 5. The total opportunity equal 25, means 5 into 5 equal 25. So the correct opportunity, that means the total opportunity minus the total number of error. What means? How many, this is we calculate the defect, okay? So what is the total opportunities we have? What means total opportunity? How many chance that we have in this example for error defect or free error? What that means? This is the 5 and this is the 5. How many chance we have it here? How many? You can calculate it. 1, 2, 3, 4, 5. Or you can, this is 5 times 5. How many equal? 25. This is opportunity of having defect or not having a defect. Okay, this is the total opportunity for the total sampling, okay, into total parameters. How many opportunity, how many chance we have for defect or for free defect, for error or without error? How many opportunities we have? How many chance we have? We have 25. Okay, from this 25 we have 11 defect, means 11 error. So how many free of error we have? Just you need to take 25 minus 11 to give you 14. Okay, okay, let us go to the Six Sigma calculator. We need to calculate the Six Sigma level for this villa, or for this scenario, or for this example. How many, what is the Six Sigma level we have right now? So as we mentioned before you start your project, once you get into the company, you need to calculate the current Six Sigma level you have in the company, and then you will report it to the management. You will tell them, guys, come here. Your Six Sigma current Six Sigma level is 1 or 2 or whatever. Our target to move you from the current one to the Six Sigma level. So now in the first stage, we are calculating the current Six Sigma level without doing anything. This is the current situation. We just get in from the door and just we put our paper and just we calculating. We didn't do anything yet. Okay. So let's go for the Six Sigma calculation. Six Sigma calculation, there is a three number. You have to take it from this example. We need the unit. Where is the unit? This is the unit. Remember, guys, we said unit, it's number of sampling. If you take 10, the unit will be 10. If you take 20, the unit will be 20. 19, 90. Okay. Now we need the unit. How many units we have? Come on, guys. 5. Okay. Okay. We need the opportunities per unit. The unit we have 5. Yeah. The opportunity per unit here. Opportunity per unit, the number of parameters. I put it wrong, the total opportunity. Here only we put the number of the total opportunity of the parameters. How many parameters we have? We have 5 parameters. How many unit we have? We have 5 or 5 units. The defect we have 11 defect. So our Six Sigma level, the current Six Sigma level is 1.6. So this is the 1.6 what we have. Okay.
Okay, no.
Here there is a number. If you remember, before I told you the Six Sigma level, it's about 3.5. What is 3.5? 3.4. 3.4 defect per million. Now, how many defect per million we have? We have 440. You remember 440 where it has to be? It has to be here in between. This is 3 something. That means above 2 Six Sigma level and in between 1 Sigma level. 1 Sigma level, you don't have number for that one. That means you are working in between. That means your current Six Sigma level is between 1 and 2. You are working in this area. If we said there is 1 here, that means your current Six Sigma level is 1.6. 1.6, it has this number of defect, and this number of defect is between 2 and 1 Six Sigma level. Your target has to be 3.4. What means 3.4 defect per million? Okay, guys, clear this sample example? Okay, this is what we call it. We call it pre-Six Sigma level. What means before you start your project, you will do this calculation in order to calculate the Six Sigma level you have. Now we are in between 1 and 2 Six Sigma level. We need to move. So what we need to move, that we need to do something. Okay. So after working on this villas, after the real estate start doing some fixing some defect, we have this picture. The villa one, we used to have, I think, 3, correct? 3 defect. We
Yes.
used to have 3 defect, and then they work on the process and they fix. All error has been fixed. We used to have 11. Correct, we used to have 11 defects. After restructuring, new process, new procedure, maybe
8
training
errors.
for the staff.
33.
Now we fix all
8 errors.
electricity, all the water, all the ACs, all the doors, all the windows has been fixed. So we have only this type, this number of errors. So instead
3.
of have total number of errors or total number of defect, we used to have 11 here. Now we have only 3. Okay. The parameters is still the same. The sampling is still the same. So the total opportunity, it will be the same. But which one it will be different? The correct opportunities. So the correct opportunities, instead of we have 14, here we have 22. Instead if we have total number of defect 11, now we have only 3. So let us go to the Six Sigma calculator again. How many defect we have? We have
3.
instead of 11. So now your Six Sigma has been increased. The DPO, defect per million, have been reduced. Okay.
Intention.
That means you moved from in between 1 and 2 Six Sigma level. We used to be between 1 and 2. Now you will be in between 2 and 3 because this is 2 point something. That means that this is 120,000 defect per million. So in each million process, you have 120,000 defect. That means you are in between 2 and 3 Sigma level. What that means? That means you jump 1 Six Sigma level. Can you see the difference, guys, between this picture and this picture? This is only 1 Six Sigma level. 1 Six Sigma level. See how many defects we used to have. After working on Six Sigma level, Six Sigma project, after doing the restructuring, after reviewing the process and procedure, we have these errors only. Instead of we have 11, we have 3. And all this one jump 1 Six Sigma level, only 1 Six Sigma level. So we used to be 1.6. Now we are in 2.67. In 2.67. That means we jump only 1 Six Sigma level has been improved. Imagine if you are working more, you need to move this real estate from 1 Six Sigma level to 3 to 4 to 5 until you reach Six Sigma level. See what is doing the Six Sigma and what is the impact of applying Six Sigma in your company. It will give you a huge difference. It will move you from one point to another point, and it will be totally different. This is, we call it in post project Six Sigma. Means we did something here, and this is the result. And this
After
is
the
what is
implementation.
powerful. This is after you finish your project. You will tell the management, we have been moved from 1 Six Sigma level or 2 Six Sigma level to the current situation. That means we move only 1 Six Sigma level. So are you satisfied? This is what you need. If he said yes, okay, close your project and finalize. If there is no, we need to improve more, then you will work on the process, you will work on the procedure, you will try to remove some defect, and you will try to reduce the number of defect per million or the total DBOM. Okay, guys. So there is a one thing you need to mention here. In the exams, I will ask you for Z or calculate the Z. Z means Six Sigma level. Okay. Z is referred to Six Sigma level. So when he asks you about Z, that means he need Six Sigma level. Okay. Z, you will use the calculator in order to calculate the Z or Six Sigma level. How many numbers you need to take care about? You need to get 3 numbers from the example that he will give you. Okay. During the exam, you need to keep calculator open. He will ask you about Z level, and then you will go to the calculator. You will calculate the Six Sigma level, and the answer it will be on the selection. So you need to select which one is correct. Okay. In the Six Sigma level, calculating the Six Sigma level, you need 3 numbers. You need the total opportunity. Okay. You need total. Yeah. Yes, Bali. Only 5 minutes. You need the total opportunity. This is the one number. You need the unit. This is the number. You need the number of defects. Three numbers that you needed to calculate the Six Sigma level. In the other, we have something called DBU. Okay, guys, what means DBU? DBU means defect per unit. In each unit, this is a unit, correct? This is a unit. We need to calculate how many defects we have per this unit. There is a law for that one. The DBU, what is equal? Total number of defect, this one, okay, divided into total number of units. What means? The total number of defects here, you have it. You will divide it into total number of units. This is a number of units. How many units we have? We said unit means sample. How many sample you have?
5.
We took 5 samples. So the DBU equal the total of defect. How many defect we have? Here we have 3. Okay. And how many the total of number of units? And actually he will give you sample. The later we will go the next slide. There is a 2 or 3 sample we will take. Example we will take in order to get more. For example, he will give you like this one. Okay, this is in Arabic. Sorry, I forget also to translate. We will take it from here. Okay, if the A end of user services, compute and services, there is a 76 spare keyboard or handed audit. Okay, they found 5 keyboard is not working or is not functioning. Okay, that means out of this 76 you have 5 is not working. Okay, so you have 5 defects out of 76. Okay, this is, you have the number of the sampling and you have the number of defect. Okay, the equal is to 6.6 defect and 93.4 are good. So what that means, here is giving you the accuracy. Okay, and he is asking for the Z score. So the Z score, what we said, Z score is about Six Sigma level. Okay, let us take this example. For example, here he need to calculate the Six Sigma level. Okay. There is a quality inspection at Roni operation inspect for. This is what? This is a unit. Yes, we need to mention this is a unit. Okay. The four characteristic display, keyboard, batteries, and speaker. No, sorry, this is not a unit. This is a parameter, which is a opportunity per unit. Okay. In the mobile before backing, there is a 500 mobiles were inspected are the 116 defect were were observed. That is the output. What is the computed Z6 sigma level? He needs a 6 sigma level. Okay, we need to take three number from this example. We need the parameters, we need the unit, okay, and we need the
Error.
and we need the number of samples. So we have it here. Let us go for the 6 sigma calculation. How many units we have? Okay, were inspected and 116 defect. What that means? This is a defect per million. We have 116. Okay, guys. So opportunity per unit, how many we have? We have 500. And how many opportunities, how many units we have? We have 4. We have 4 units. Let us calculate the 6 sigma level. The 6 sigma level is 6 sigma level. So what is the correct answer here? A, B, C, D.
A.
A. So A is the correct answer. Okay. Okay, guys. So this is the way of asking the question. He will give you example like this one. What you need to focus? You need to focus on 3 number. This is 3 number you need to get. You need to get the unit, the number of unit. You need to get the unit means the sample. How many sample we have?
Parameters.
We have 4 sample. So this is the number of unit. Okay. The opportunity per unit. How many opportunity per unit or the parameters we have? 500. How many mobiles we have? We have 500 mobiles. Defect. He mentioned here defect. 116 defect we have. So the calculation is 3.07. This is a 6 sigma level. And this is the answer in the question. So this is when he asked for Z. Now he is asking for the DPU. Okay. In the DPU, you have to take care of only 2 numbers. The 2 numbers you have to take care about. What is the 2 number? You need the total number of defects and you need the number of unit. Okay. In an inspection of 10 TVs, 40 defect has been found in 5 TV. Rest of the 5 TVs has no defect. The defect per unit DPU is computed as he gives you this number. He gives you these choices. You have to choose one of these. So let us go for the law. The DPU equal total number of defect. Where is the defect? This is a defect. 40. This is the total number of defect. Okay. We will divide it into number of unit. How many TV? 10. He said 10 TV. Okay. 40 into 10. How much? What is the correct answer here?
4.
4. Yes, right. You are right. Then the P. Okay, guys. This is the calculation we have here. We have a DPU and we have Z level. Z level, you need to take care of 3 numbers: unit, opportunity per unit, and number of defect. In the DPU, you have to take care of only 2 numbers. And in the DPU, no need to use a calculator. If you are good in mathematics, you can do it without any calculator. In the Z level, you need to use 6 sigma calculator. Okay, guys. this is what we see today. This is a major phase. Tomorrow, inshallah, we will go for the analyze phase. Any question, guys?
Assalamualaikum.
Sir Bali,
So, whether can you please provide the
as I promised, only 1 o'clock.
this a copy of the two classes?
Sorry?
This a copy of the slides for
Yeah,
the
sure.
last 2 days. Yes.
Right now, right 1 hour, I will send you.
Okay. Okay. Thank you.
Okay, guys?
Okay, thank you.
Welcome.
Thank you.
You are welcome.